In this lesson we're going to show you how to graph a system of inequalities. It's a little bit different than graphing the system of equations because of the range of solutions that could happen, kind of like when we did the shading on a number line when we were solving them. The most important part about today is finding the common region. We'll talk about what that is on the next slide. Okay, on this slide what we have going on are two inequalities happening at the same time. And you notice that now we have x and y in both of these. We're going to graph them just like we did with single lines, just going to graph two of them. So we do need to consider whether these are going to be dotted lines or solid lines, whether we're going to shade up or we're going to shade down. So let's take a look at the first one. The first one looks good to go. It's in y equals mx plus b form, but the second one isn't. So let's get that one ready to go by dividing everything by 2. And then rewriting. Y is greater than 1/2 x minus 1. Now I'm ready to graph both of these. Let's start out with the top equation. We're going to do this one in green and the red one in red. Plot our y-intercept first. Do our slope of 2 over 1. Rise 2, run 1. You can do this over and over again if you feel like you need to in order to make a better line. You can also reverse it the direction to also make a good line as well. Now, since this is a or equal to, when I do the line, I'm going to make sure that it's solid and make sure that it goes all the way pretty much as big as I possibly can make it. Okay, let's look at the second problem, the red problem. The red problem has a y-intercept of -1, which is about right there. It has a slope of 1 over 2, so rise 1, run 2, and again, and again, and again. You want to do this as many times in both directions as possible. I'm assuming that we are all familiar with how to use a slope and an intercept. Now this one does not have an or equal to, so I'm definitely going to make this into a dotted line. There we go. Now here comes the most important part, is the shading. Now that I got my dotted and my solid lines all ready to go, let's talk about the green problem. The green problem has a less than, so we are definitely going to shade down from the green line, which will be everything in here. You want to shade as much as possible. There we go. And now we look at the red problem. The red problem has a greater than, so we're definitely going to shade up. And that means it's going to be all of this. And the most important part is that overlap. You see where the green and the red both overlap. I'm going to highlight it in pink so it pops out. This section right here. This is called the common area. Okay? That is the actual solution for the inequality, the system of inequalities. Okay? Common area, or the solutions. Okay, let's take a look at another one. So in this one, neither of the inequalities are ready to be graphed, so we're going to have to change both of them. Let's first change up the top one by minusing x, so x plus 2y less than 5, minus x, and we get negative x plus 5, and divide by 2, and we get y is greater than negative 1/2 x plus 5 divided by 2 is approximately 2.5, actually exactly 2.5. Now let's work on the other equation. 3x minus y is greater than or equal to 4. Minus 3x on both sides, and you get negative y is greater than negative 3x plus 4, and divide everything by our negative ones. And we get y, switch the sign because I divided by negative, positive 3x minus 4. Okay, let's graph both of these. Start by graphing the green, putting a y-intercept at 2.5, just approximately, the best you can. We're going to go down 1 and right 2 for negative. Down 1, right 2 puts us here, then again, then again, and again, and again. Go opposite direction. There we go. And so on. Dotted line, a solid line, no equal or equal to on this guy, so we are going to put a dotted green line. It's okay if a couple of my dots are a little off. This is a pretty good line. Now let's do the red line. Red line is at y-intercept negative 4. We're going to rise 3. 1, 2, 3, run 1. It's about here. Rise 3. 1, 2, 3, run 1. 1, 2, 3, run 1. 1, 2, 3, run 1, and so on. Again, look for the or equal to or not. I don't see one, so another dotted line. That looks like it fits it pretty well. So I'm going to challenge myself and see if I can figure out where the common area is without doing too much shading. So I'm definitely going to go down from the green, and I'm just going to put some helper arrows in here just for a second, okay? I'm going to go down, down, down. This is the area I want to go down from the green, but I want to go also down from the red. And so that'd be down, down. So the area where the arrows are both pointing down would be this area right here. See? Both sides. Now I could have done the double shading like on the last slide, but I challenged myself to see if I could just shade one area, one common area. Our last example is going to be one where we just have two simple one variable inequalities. These are still graphable, so I'm going to still go to our x, negative 3, put a dot there. Oops, switch over the pen. There we go. And now I'm going to go ahead and draw a dotted line going down through this point. The other one is at x positive 2. Right there. And let's see if this one has an or equal to. It does. So this one is definitely going to be a solid line this time. Now let's look at the shading. I need to go greater than negative 3 and less than 2. Greater than negative 3 would be going to the right. Less than negative 2 would be going to the left. And so the area that I'm going to shade in is the area right between them. This is the common area. Okay, so that's what you do. You do your horizontal or your vertical lines depending upon if it's x equals or y equals, and you still shade in normally. So don't let that trip you up just because we don't have a y-intercept and slope and all those things. Okay, if you have any questions, leave a comment.